still, it's fun to play. Help me out. What's that on the head? Is that ice cream? Snowball? That's an ice cream cone, yeah. It's okay. Very nice. Yeah. The pancakes on your head. Look at that. Very good. Anybody still trying to get in? I can't hear you. Are you still trying to get in? Okay, I'm gonna go. All right, I think you can still get in. Keep trying. Yeah. Okay, so descriptive statistical terms. Dun, dun, dun. This distribution of income is normally distributed as red, exhibiting negative kurtosis is blue, skewed right to high values is yellow, and skewed left to low values is green. Very good. Majority of folks hit it. Okay. And so remember the Java. His tail is skewed to high values. I know you can read that, so come on, no excuses. All right. Next. Oh yeah, leaderboard. Okay, good job, Keaton. Okay, this is an example of blank. Quick thumbs. Oh, who did that? I'll take a picture if it's perfect, but so this is normally distributed data. It's so symmetric, so that's in, yeah. Maybe they thought it was a little too peaked. Okay. Thought I was being tricky. The tallest bin, most probable, is the blank, the data. I made this real fast this morning, so I hope I didn't like copy paste error and give you the wrong answer. I'm looking at this and I'm doubting. Oh, good. Yeah, it's the mode. Oh, so close. Yeah. Otterhound deaths. This distribution is blank. There may be two right answers. Just pick the one you like. See, blue was correct, but also red. It's bimodal. So let's look at that. Can you see the two modes? Yeah. So this is a little bump up. That's not normal, right? Well, none of it's normally distributed. But my point is, your skewed left would just kind of come down like this. But then all of a sudden, we just a little extra bump. So that little extra probability here, it means there may be another distribution here that's also skewed left. So we have two skewed left distributions. We have the main body and the minor component. And whenever we see that extra non-statistical bump, we call it another mode. So it's multimodal or bimodal since there's two. And so you might look at this and say, wow, okay, this is something happening early for a small population and then the rest of them. I don't even know what an otterhound is. I just went on Google and said, find me some bimodal data. Number 5, the forensic chemist results were not normally distributed, so their work should be suspect. I'm predicting this is going to be a coin flip with you guys. Not so much. It's, yeah, I would say false too. That's the way I put it correct. But, you know, we only have 10 data points. So, yeah, there's no decision or no action needs to be taken. So I wouldn't be too worried about it. Someone's on fire. All right, number 6. U.S. spending on science. This goes back a few lectures. U.S. spending on science correlates with suicide by hanging. True, false, so what? Pick which one you like. It definitely correlates. Look at the correlation coefficient. It's like where is that? All of these are like 0.98. Like the R squared is 0.98. They correlate. Okay, they're spurious correlations. There's no connection to this data. It just happens to go up the same. And so what? I mean, correlation is not causation, so there doesn't have to be a causal connection to these things. So it would be true or so what. If you could click both, you'd click true and so what. Okay, yeah. So, gotcha. I'm trying to, but trying to emphasize correlation's not causation. Just because 2 data points go up the same and go down the same and go up the same. And so you can go to Tyler Vegan's website when you're bored and or type in spurious correlations, and you'll see the funniest ones ever. And we'll look at them here afterwards. Okay, let's do the leaderboard. Dun, dun, dun. Hey, good job. Cute glasses. Oh, getting close to Valentine's. Dun, dun, dun. Good job. Runners up. Very good. Okay, that was fun. All right, that's all I've got for today.